This video, we are going to discuss two basic operations that we perform on a linked list. One is called traversing the list, and the other is trying to figure out the size of the list. In other words, counting the numbers of nodes that we have on the list. Now, traversing the list is a very important operation, so it's very important that you understand the mechanics behind the code that I'm about to show you. The reason for that is we can traverse the linked list for many reasons. First, let me tell you that traversing the linked list means that you're going to start on the very first node of the list, and then one by one, sequentially, you're going to visit, you're going to access every node that there is on the list. So if we have a list of, let's say, 150,000 nodes, traversing the list means that we are going to have access to each of those 150,000 nodes one by one, sequentially, starting with the very first one. So you remember there is a reference called next. So once we start with the first node, we do whatever we want to do with it, and there are many things that we can do with a node once we have access to it. But once we're done with that, then we're going to go or move to the next node, and that would be the second node. And once we finish doing whatever we need to do with the second node, we're going to advance to the next node, which will be the third one, and then the next one, which will be the fourth one, and then the next one, so on and so forth. So we are traversing, we're accessing the nodes on the list one by one from the very first one to the very last one. Counting the nodes is obviously what it does, and you're going to see that it's a very similar code because if you think about it, in order to count the nodes of a given list, you're going to have to traverse the list, access every node, and keep a counter. Every time that you access a different node, then you increment the counter by 1. Once you finish traversing the entire list, you should have the count that represents the total number of nodes, the size of the list. Traversing a list, in this case, I'm going to show you how to print every node on the list. So you're familiar with this instruction in Java that is used to print one value per line. And essentially what we're going to do is to print the value of the node that we are currently looking at. So how do we access the node? I assume that you have watched the video where I discussed the class myNode. Okay, if you haven't done so, this will be a good time to watch that video and see the fields and the method of the class myNode. So once you do that, then you're going to see that there is an accessor called getData and an accessor called getNext. And obviously those give you access to the value of the data, which is an object, and to the value of next, which is a reference to the next object on the list. So what do I want to print? What I want to print is the value of the object. The object will have a method, probably to a string, that allows us to print on the screen the data that is contained in the object. So front.getData is simply saying, okay, let's print the data that is in the node. Okay, and what is front getNext? Again, it tells us to retrieve the value of an address, and that will be the address of the next node. So if I'm at this point, is front has the value of the node that has the t, when I say getNext, it's going to give me the node that is next to t, that goes after, okay, that follows, and that is the node that has the o. And when I say getData, and again, if I'm looking at t, in this case, well, t is a single string, and it's just going to print capital T. Okay, so now, how do we traverse? Well, we need a loop, right? So here you see that I have a while loop. I'm not using a for loop because normally for loop is using for indexes. But remember, linked lists, we don't have indexes. This is not an array. This is a collection of nodes, and we have to deal with reference. So I have a loop that says, okay, every time that I access a node, I have to do two things. First is to print the value of the field that I call data. That's the object that is stored in the node. And once I do that, I need to advance to the next node. This is the second statement. And I have to do those in that order, by the way. I should not advance to the next node and then print. It's very important that you realize the difference between those two. So this is the correct order. First, print the data of the node that you are looking at, and then move on to the next node. So you see that I'm using this value called front. So what is front? Front is a parameter that is being passed into this method called traverse, and as the word indicates, that is the address of the first node. So this is a reference to the first node. In order to traverse the list, I have to make sure that I have a list, that I have a collection of values, or at least one value. It could be that the list is empty. That is not a mistake. It's very common. So you should always have a condition that checks for whether or not the list is empty. So in this case, my condition is checking the value of front, and I'm making sure that the value of front is not null. Remember, front is a reference. Reference in Java has only two values. Either they refer to an object or they have value null. So in this case, I'm making sure that front doesn't have value null. Because if it does, what does it mean? Well, it means that my list is empty. I don't have any nodes. If front is null, that means that I have a list that is empty, and therefore I shouldn't print anything. Okay? But if front is not null, then I know that at least I have one node. It's very important. I don't know how many nodes I have. So I could not have a loop that says repeat this n numbers of times, because when I'm giving a linked list, I'm not giving the total numbers of nodes or the size of the list. I'm only giving the address of the first node. That's all I need. That's all I know. So if front is not null, I have at least one node. Well, let me display the data, and then let me move to the next. What's going to happen? When I move to the next, okay, I'm changing the value of front. So front, the very first time around, is looking at the first node, the one that contains the G. Once I finish printing the G, what is this statement going to do? This statement is going to change the value of the front. So the value of the front will not be the address of the first node. Will be what? The address that follows the one that I'm looking at. Right now I'm looking at the node that has G. G has a next field that tells me where the next node is. So when I say front.getNext, I'm changing the value of front with the value of this reference. So front is now looking at T. And then my loop repeats. Well, because front has a value of the address of T is not null, then I will again print the data, it prints T, and now I need to change again the value of front. But remember, front now is looking at T, so now I need to give it the value of this address, which is next. And that will be the address of the node that has O. And again, that is not null, then it will print the data, it will advance to the next. And this is very important because right now front is looking at the last node. Visually, I know that I'm looking at the last node. Internally, or in the code, I don't know that, but we're saying change front to front.getNext. When that happens, then front will have the value null. And then when I check the condition in the loop, this condition will be false because front now is null, and then the loop is stopped. But I have printed the G, the T, and the O. I have printed the data in every node. So at this moment, probably you should pause the video and take a look at the code and try to do a simulation by hand as I just did, and also try to understand why the order of these two statements cannot be reversed. Also, you may try to put this statement at the front and see then what happens. Okay, let me show you now the other thing that we normally do, which is to calculate the size of the linked list. In other words, we count how many nodes we have. So now I have a method called size. It's obvious the reason for that, and this method is going to return an integer. What is that? Well, that is something that I say count. In other words, I'm going to have a local variable, which is an integer called count, and it's going to be used to count the numbers of nodes. And obviously, at the beginning, I initialize that to 0. So again, I don't have indexes. I cannot use a for loop to change value of indexes. All I have is the address of the first node, okay? I know where the linked list starts. That's all I need to know. So I'm going to use a while loop, and I'm going to use the same condition that I had before. Why is that? Well, because I know that there is only one reference in the linked list that will have value null, and that's the reference contained by the last node. So when front has value null, that will tell me that I have traversed all the nodes on the list, and I need to stop. So at the very beginning, assuming that we have a list, remember, it is possible that the list will be empty. So it's possible that front value will be null, in which case this while loop will not execute at all. And then I simply return count, but count has the correct value, which is 0. So the size of the empty list should be 0. But assuming that we have a list like the one here that has 3 nodes, then front is not going to have value null. Front has the value of the node that has the G. So because I found a node, I need to increment my count. So my count is now 1. And then what do? Same thing that I did in the previous method. I need to see if I have a second node and move to it. In other words, I need to change the value front. So I'm going to change it the same way as I did in the other method by simply saying, okay, let me use this getNext method, and that's going to say, all right, so that gives me access to this node. So I change the value front to be the address of the second node. Front will not be null. Oh, that means I have a second node. Now count is 2, and then I need to move to the next one. And yes, there is a next one which will be this O, so it's not null. So this condition is true. Count is now 3, and then I'm going to move to the next one. But the next one says, oh, there is no next one. So the value of front, according to this statement, is going to be null. So when I check the condition again, this condition becomes false, and I stop the loop. I have traversed the list. But remember, count is 3, so now I'm going to return count, and then that will be the end of the method. So I have traversed the list to count the numbers of nodes. So traversing a list could be used to print the values of the nodes on the list, could be used to count the numbers of nodes on the list, could be used to search. If you think about a method that as a parameter a particular value, then we're going to search for that value. How do we search? We search sequentially, starting with the first node. So there are many applications to knowing how to traverse a list in Java. So this is the end of this audio. So I encourage you to copy and paste these two pieces of code and play with it.